States, approximately 410 amputations are performed each day. Within the first 2 years post-amputation, the residual limb undergoes large volume changes that can compromise the fit of their prosthetic socket, leading to a need for some means to compensate for that volume change.
Currently, layering prosthetic socks and padding is used to do so. However, these solutions can only be so effective, as many prosthetic users find themselves needing an entirely new socket every 3 to 6 months within the first 2 years post-amputation. This solution also requires the user to manually take their socket on and off for adjustments. Additionally, between 50 to 90% of lower limb amputees have peripheral arterial disease and/or diabetes, which makes them even more susceptible to large volume changes.
Hello, I'm Tony Gutierrez with Bionic Prosthetics and Orthotics, and I helped out with this project in looking at adjustable socket systems. The prosthetic socket for a lower extremity amputee is one of the most important parts of the prosthesis. Oftentimes we see, especially in acute amputees battling dysvascular disease, that a lot of residual limb volume fluctuation occurs in the first year to year and a half, often necessitating multiple socket changes, padding, revision to the sockets in order to maintain a stable limb environment. The use of adjustability in sockets has been present in our industry for the past couple years and has had some success, but one of the biggest challenges in that is complex fabrication or design of the prosthesis and cost to the patient. Really looking forward to partnering with this group to see what kind of innovation they're going to bring to look at how adjustability in sockets can be brought towards more adaptability and usability in patient care.
An ill-fitting socket can lead to many complications. An over-tightened socket can lead to loss of circulation, pain, and tingling, while an under-tightened socket can lead to blisters, rashes, and inefficient gait and balance. This clinical problem drove the need for a way to accommodate those large volume changes in the first 2 years after an amputation.
Here at Purdue University's Weldon School for Biomedical Engineering, we prioritize innovation and strive to use patient input to create a device that best suits them. In a survey taken from a community of below-the-knee amputees, the top 2 aspects they find most important are comfort and adjustability. Our device, ResiComfort, is designed to provide an automated adjustment of the prosthetic socket, accommodating to volume changes experienced by the limb throughout the day. This reduces the need for the individual to manually increase or decrease the cushioning in their socket, with the device instead inflating and deflating an air bladder on its own to support and cushion the limb automatically.
ResiComfort is designed to be incorporated with any prosthetic socket and to fit the shape of the patient's individual residual limb. Our design features 3 main components: the air bladder, the micropump, and the pressure circuit. The air bladder encircles the limb completely, sitting between the residual limb and the prosthetic socket itself. Pressure sensors on the inside of the bladder are connected to the micropump, which sits in a protective box on the outside of the socket with the other electrical components. Based on feedback from the pressure sensors, the micropump will inflate or deflate the air bladder to maintain the pressure between the limb and the socket in a safe range. This ensures the socket fits snugly without cutting off circulation for the patient. This will also decrease the chances of blisters or rashes from wearing the prosthetic for long periods of time, prioritizing the comfort of the user.
To use ResiComfort, all you have to do is simply place the limb inside the bladder. With the push of a button, the bladder inflates, securing the limb snugly in place.
Our device is made to be affordable for the patient, even without insurance. The materials were chosen for the combination of their functionality and low cost. For instance, by using the same material as bladders found in blood pressure cuffs, the device is made to be durable, while still remaining cost-effective for the patient. In addition to reducing the cost of the materials, the device also reduces the need for additional prosthetic refittings. The device can adjust the fit of the socket to accommodate large volume changes, so it reduces the need for additional prosthetic sockets, ultimately resulting in fewer expenses for the user.
With ResiComfort, we hope to allow people to quickly regain their independence and push past their limitations.